one, topic 6.1. Find the areas between two curves. Number 4, we want to find the area between the curves sine of x and cosine of x within the interval of 0 to pi halves. First I'm going to graph this. Okay, so we're going to go from 0 to 2 pi, halfway would be pi, and halfway between that would be pi halves. Okay, the sine wave has a period from 0 to 2 pi. So let's put it here, -1 to 1. And we're going to go to this high, here, here, and there. That'll be our pathwise sine wave. The cosine wave starts here. Let me put that in another color. And then at pi, we're at 0. I mean -1. Here we're at 0, we're at 0, and here at 1. So cosine. Okay. So there's a cosine. So we'll call this one y2. And this will be y1. Okay. We want the area between 0 and pi halves. Right here. And what we have here, the upper curve here is the cosine, the lower is the sine. The upper curve here is the sine, lower is the cosine. Okay, 2 ways I can handle this. I can actually split this up right here into pi fourths, and do 2 equations. Now, since both of these are reflections about pi over 4, I can just do 1 equation and multiply that by 2. So I believe that's what I'm going to do. I'm going to multiply by 2. So I'll demonstrate both, but I'll show that I can get the same answer by multiplying by 2. So we have from 0 to pi over 4 of the upper y2 minus y1 with respect to dx, because all the rectangles here will be basically widths of delta x here, plus from pi over 4 to pi over 2, the upper here will be y1 minus y2, again dx, because again we have rectangles here. It's a delta x here as a width or base. The combination of these two will be 2 times the original function, 0 to pi over 4 of y2 minus y1 dx. Okay? Because both these should have the same area since they're symmetric about pi over 4. Okay, so let's solve that. It's 2, 0, pi fourths. y2 is going to be cosine x minus y1, which is sine of x, all dx. Okay, we'll take an antiderivative of this, and this will be 2, and the antiderivative of cosine, which will be sine of x. The antiderivative of sine of x will be negative cosine x, giving us a positive cosine x here. And that'll be from 0 to pi fourths. Okay. Alright, so let's evaluate this. Let's put in pi fourths into both of these, and we'll get 2 with sine of pi fourths plus cosine pi force minus 2 sine of pi force plus cosine pi force. Okay, just close that off here. Close that off. All right, let's look at the values for pi force. So, pi force, which is about here for my sine function, which will be, let's see here. I'm sorry, this should be 0 in here. This should be 0 as well. Okay, so sine of pi force is going to be the square root of 2, and the cosine of pi force is also going to be the square root of 2. Okay, and when we add these, we'll have 2 times the square root of 2. 2, when we add these, you get square root of 2. Minus, the sine of 0 is 0. The cosine of 0 is 1. So this will be minus 2 times 1, which is 2. Okay, so the area will be 2 times square root of 2 minus 2. Or we can factor out the 2 and have the answer square root of 2 minus 1. Both of these are acceptable answers. Number 6, we want to find the area between the curves x equals y squared minus 4y and x equals negative y squared plus 2y. Okay, I'm going to graph these first by exchanging x's and y's and looking at the graph as the inverse function. So y equals x squared minus 4x. I can see that this has a x-intercepts. I just basically factor out my x, and I can see I have an x-intercept at 0 here for this, and at positive 4. And it's positive, so my parabola will have this look. Okay. Now, when I flip this over to x equals y squared minus 4y, we will get a reflection about the diagonal here. And so that reflection will give me, this 4 will go to here, it will be a positive 4. 0 will remain. And this is what my graph will now look like. Okay, so this is my graph. Next, we want to graph x equals negative y squared plus 2y. So I exchange my x's and y's and get y equals negative x squared plus 2x. Now I'll factor out a negative x. What this now gives me are x-intercepts of 0 and positive 2. And my graph leads with a negative, therefore it will be upside down. Okay. Now I'm going to create a diagonal and flip everything across that diagonal, creating x equals negative y squared plus 2y. And that's my graph. And you see that it is not easy to take, let's blow this up a little bit. It will not be easy to take rectangles here because of this point right here. Because we can get a rectangle, a vertical rectangle there, but then it changes. This right here is its own bottom. So you can't have upper and lower for the same graph, and then upper and lower for two different graphs. Sorry, you can certainly have it for two different graphs here, but not for the upper and lower here for the same graph. So we're going to attack this by finding horizontal rectangles. Okay, in the horizontal rectangles, we'll have delta y's. And the lengths here will be x's. So let's do it. Right side minus left side. So the lowest point right here will be 0. And then the highest point that they meet at, I need to find out the intersection so I can find out where do they meet here, y value wise. So let's set these equal to each other. Let's get rid of the interval. Okay. We'll take the additive inverses of all these and put them on the other side, so we'll get 0 here. And so we get 2y squared minus 6y. Now I'm going to factor out 2y. This will give me two y-intercepts. A y-intercept of y equals 0. And a second y-intercept of y equals 3. And this will be my limits of integration from 0 to 3. 0 here to 3 there. Okay. And this will be the right side minus the left side. My right side, which is this curve right here, so here, this is my x2. Minus x1, which is this one. And this will be all with respect to y, because I have delta y's here. It's a little hard to see, it's kind of small. Those are delta y's. And that's a delta y as well. Okay, so let's go ahead and solve this. 0 to 3, x2, which is negative xy squared plus 2y, minus my quantity, y squared minus 4y dy. This simplifies to negative y squared plus 2y minus y squared plus 4y dy. I'll further simplify this. Okay. And then from here, I want to take the antiderivative of this polynomial. Okay, now I'm going to simplify these coefficients here. We're going to get negative 2/3 y cubed plus 3y squared. And also this will be evaluated from 0 to 3. Okay, let's put 3 here and here. So we get negative 2/3, 3 2/3 power, plus 3 to the second power here. And then minus 0. Because 0 in each of these will give us 0. Okay, so 3 to the third power is 3 times 3 times 3 divided by 3 is only 3 times 3, which is 9, times negative 2, which gives us negative 18. This will be 9 times 3, which will be 27. And the difference between, the sum of negative 18 and 27 will be 9. So the area between the two curves will be 9.